So we talked about linear functions. Let us discuss quadratic functions. So for quadratic functions, you have general form f of x equals to ax squared plus bx plus c, and we usually mention that a is not 0, because if a is 0, this guy just becomes a linear function. Okay. So let us go over one example and show you how to find x-intercept and y-intercept of a quadratic function. F of x is equal to, I'm going to give you a very easy example, x squared minus 4. So basically for this example, like what we did before, we're interested in finding x-intercept, right? X-intercept or x-intercepts. At which values, at which points, this graph actually hits x-axis. So remember that to find x-intercept, we set f of x or y equal to 0 and solve for x. Very good. So I have x squared minus 4 equal to 0. To solve this equation, you have two options. Option 1 is to write this in factor form. Remember that if you have x squared minus a squared, this is x minus a times x plus a. So basically, I'm saying x squared minus 4, which is x squared minus 2 squared, x squared minus 2 squared, which is x minus 2 times x plus 2. I'm setting this equal to 0. The multiplication of two quantities is equal to 0. So x minus 2 is 0, x plus 2 is 0. By solving the first one, x is 2. By solving the second one, x is minus 2. So what does it tell me? It tells me, hey, this graph has two x-intercepts. We have two x-intercepts. One of them is 2 and 0, remember? 2 and 0. The other one is minus 2 and 0. We can graph this. We can easily visualize this. We can verify that. Let's take a look at Desmos. Let me have Desmos ready. So we can take a look at this quadratic function. So this was a linear function that we discussed. And we're moving on to y equals to x squared minus 4. This is your quadratic function, the blue one. The graph is called a parabola. And as you can see, it hits x-axis at 2 points, -2 and 0. The other one is 2 and 0. At 2 points, this graph hits x-axis. So algebraically, we showed that they have two x-intercepts. And geometrically, we can verify that. Again, this method is factoring. The other method that you can apply is you can directly solve this. X squared minus 4 is equal to 0. So I'm going to write down, or you can apply either of these two methods to find x-intercept. So once you set x squared minus 4 equal to 0, we can add 4 to both sides. X squared becomes 4. Then we're going to take square root of both sides. Taking square root of both sides, square root of x squared equals to square root of 4. It's a common mistake that students just write x equals to 4, square root of 4, or x equals to 2, which is not basically the answer here. This on the left-hand side gives you the absolute value of x. And on the right-hand side, you have a 4. It says the distance between x and 0 is 2. That's the definition of absolute value, as you remember. So let's delve into detail. This guy says the distance between x and 0 is 2. So remember that on the line, you have 0, you have 1, you have 2, you have 3, some positive numbers, and on the left-hand side, you have some negative numbers. The distance between x and the origin is equal to 2 units. So of course, 0 is here. 2 units to the right gives me 2. This was the original answer that you have written. But 2 units to the left gives me the second number, which is -2. So when you're solving x squared equals to 4, the solution has 2 answers. You get x equals to plus minus 2. As we expected, we have 2 x-intercepts. 2 and 0, -2 and 0. And we prove that by the second method here. Guys, some notes. If you have y equals to x squared, this is your green graph here. You only have one intercept. Take a look at another example. If you have y equals to x squared plus 4, this is this purple graph here. There is no x-intercept. This graph is completely above x-axis. There is no intersection between this graph and x-axis. So each graph has a different behavior. And make sure to do the algebra and definitely visualize this so the visualization supports your algebra. Now for y-intercept.